All right, so continuing with section 9.7. So today the new information will be law of cosine. And so again, it's, what do I do to figure out the, let me put the law of cosine down first. What do I do to figure out length of a side or angles when it's not a right triangle? So law of cosine is definitely more work. So there's 3 different versions depending on the problem. So the first part should look somewhat familiar. It's a version of Pythagorean Theorem. I mean, the equal sign is in the wrong spot, but so it's really long. But the 3 different versions are all, if you kind of can see the pattern to it, then it's a little bit easier to remember. So let me finish the last one. Okay, so it's kind of just the 3 different versions of Pythagorean Theorem at the beginning. A squared equals b squared c squared, b squared equals a squared c squared, c squared equals a squared b squared. It's just, kind of move them all around. It's always -2, so that helps. And then the BC here is the same as like what's on the right side of the equal sign. So b squared and c squared, it's b and c, so bc go there. It's a squared and c squared, so ac go there. And a squared b squared, so ab go there. And then it's cosine of the very beginning, a squared, or cosine of b, cosine of c. So depending on what you're trying to find, are you trying to find a side that's A? Are you trying to find the angle that's A? Are you trying to find the B? Like, will depend on which one like you use. So if you're trying to find either A, the lowercase a is the A side, the uppercase A is the A angle. If you're trying to find either one of those, then you would use the top one. B, lowercase b is the side, uppercase B is the angle, use the middle one, so on and so on. Okay, so I'm going to try to squeeze part of a problem in here. So let's say we had we had something like this. So I don't have, the kind of the key to the problem was like law of sine is easier. I need to have an angle and the side across from the angle in order to do law of sine. There's no way for me to come up with that on this problem. Okay, because I can't figure out angle C or angle B, which would then give me like an angle across from a side. So what I end up needing to do is, because there's no way to figure out these angles down here, I need to figure out like that side across from the 114 degrees. Okay, so I need to figure out what A is, which means I'm going to use that top version of the problem. So I don't know what A is, so I'm just going to write A squared. Okay, B. Angle B is over here on the right. The side across from the B is 23. C angle is on the bottom. The side across from that is the C. And the angle is 114 degrees. So I just plugged in everything, and now it's just a big, like, algebra problem. So 23 squared is 529. 26 squared, 676. 23 times 26 is 598. And I'm kind of like doing some things in multiple steps here, but multiply 598 times 2, and we get minus 1196. And the cosine of 114 degrees is negative, and that happens sometimes, 0.4067. Okay, and so kind of our order of operations here, like this is a multiply thing over here with this decimal. So I need to multiply that. And I also need to recognize that negative 1196 and negative, like, so I'm doing a negative times a negative. So times 1196. And I'll get 486.5 if I round it off. Okay, so add them all together. 529 plus 676 plus 486.5, and I get 1691.5. And then I need to do the square root. So let's see. Square root 1691.5 is 41.12 or 41.1. So really long to get all the way down to that. Okay. God, I can't. It would look like kind of like a weird 7. There we go. All right, so now I need to figure out angle C and angle B. So the good news is that we did this whole big long thing right here, but now I do have 114 degrees and 41.4 are across from each other, so I can use sine or law of sines, which is typically much easier to do. So I have sine of 114 over 41.1, and then it doesn't matter, pick B or C, I'll do C. Sine of C over 26. So you got to pick the side across from that to make sure like you're good. So sine 114.9135 multiply the diagonals. So let's do that. 23.7522 divide by 41.1. And so we get sine C equals 0.5779. So remember that we're trying to find an angle So that means I need to do the inverse. Okay, so second sine inverse 0.5779. And we get, finally, angle C is 35.3. All right, and then lastly, I need to find out angle B. That should be, I'll do this right down here. That should be the easier one because I know 114. I know 35.3. And I can do 180 minus 149.3. And I get 30.7. Okay, so all that work, does my answer even make sense? So remember, the biggest angle should be across from the longest side, and so on. You should be able to work your way down. So 114 is the biggest angle, 41.1 is the longest side, so that works. The next largest angle is 35.3. 26 is across from that. That's in between 23 and 41, so that, it all makes sense. Oops. Okay, so again, does it make sense is going to catch a really big mistake, not necessarily a small mistake. But if your numbers all make sense, chances are you're good. Okay, so there's one version of law of cosine where it's kind of in the book, and I'll never refer to it this way just because I don't want to confuse you, but let's see. So we started off with a side and then an angle and then a side. So if you look in the book, it says law of cosine, side, angle, side, case. It's just how's it set up. Okay, so the other version of the problem that you could see is if I had all three sides and I didn't have any angles. So so for sure can't use law of sine at the beginning because excuse me, there's no angle to have that's across from a side. So it's really just pick whichever one you want. I'll be honest, on these ones, I don't pick, first when I look at it, angle A is going to be the smallest angle because it's across from the smallest side. Angle B is going to be the biggest angle because it's across from the biggest side. And then C will be somewhere in the middle. On these kind, I don't start with the big angle, angle B. Sometimes some weird stuff can happen. So I just pick either A or C. It doesn't matter which one. I'm going to choose C because we did the A version of the problem on the last one. So remember that this is the lowercase a, this is the lowercase b, and this is the lowercase c, across from those angles. So if I'm using the C version of the problem, I start off with C squared, then I do A squared plus B squared minus 2, and then it's A and B. Since I'm doing the C version, this is 12 is A, 27 is B. So I'm using the same numbers that are here on that side. And then I'm going to have cosine of angle C. I don't know that one. So keep in mind, I'm trying to find an angle. That means I'm going to have to do inverse later. Okay, so 20 squared is 400. 12 squared is 144. 27 squared is 729. Okay, so the solving part on this one is going to be a little bit different. So I'm going to add these two together. 144 plus 729. And I get 873. And then I'm going to multiply 12 and 27. 324. And then I'm going to multiply 2 times 324. Okay, listen carefully. Do not subtract those. Okay, you cannot, because the cosine C is attached to the 648. It's not attached to the 873, so I cannot combine them. It's like having an equation, and I'm just going to use the first numbers, and x for cosine. To solve that, you can't do 8 minus 6. You would do minus 8. And then you would divide by that. So I got to do the same thing, except for it's 873. Oops, why did I put 400 there? So negative 473. And then over here I have negative 648 cosine C. And then I'm going to divide. And actually just type into your calculator, negative 473 divided by negative 648. We want the decimal. All right. I'm finding an angle, so I got to do the inverse. So cosine inverse 0.7299, 43. 43.1 for angle C. And I don't know. Yeah, it says round decimal answers to the nearest tenth, 43.1. Okay, so just always read the directions for that, because sometimes it'll say round an angle to the nearest whole number. But in the directions it says round decimals to the nearest tenth. All right, so angle C, finally, 43.1. All right, so now I have an angle across from the side. So to figure out one of the other ones, I can do sine of 43.1 over 20. And then let's find angle A. Sine A over 12. Okay, so sine 43.1, 0.6833 when you round it. Okay, multiply the diagonals, sine A times 20, and that decimal times 12, 8.1992, and then divide by 20. .4099, and again I'm finding an angle, so I got to do the inverse. 0.4099 And we get angle A is 24.19 or 24.2. All right, we're in the home stretch. Find the third angle, 43.1 plus 24.2, 67.3. 112.7. Whew. So long problems. Okay. My answer makes sense. Longest side is crossing the longest angle. Middle side is crossing the middle angle. Smallest one, smallest one. So I'm reasonably certain that I did it right. All right. So on the cosine problems, you're going to have to do log cosine and then log sine. And then add up the angles to 180 in some order. Sometimes you don't always, well, I guess on cosine you do the 180 at the end. So law of sine, problem at the beginning, you're going to do law of sine twice. Law of cosine problem, you're going to do law of cosine and then law of sine. You'll never do law of cosine twice. You can, I suppose, you could just do another law of cosine if you like that one better to figure out, angle A, like I use law of sine, but you could plug it in. Just typically law of sine people like better and think it's a little easier. So, but you're going to use law of sine and add up to 180 in all of these kind of problems. It's just a matter of, are you going to do law of sine twice, or are you going to do law of cosine once and law of sine once? Okay, so again, it's 6 problems, so it's not a lot of problems. Obviously, the problems are a bit long, since I just did one on an entire screen. And you'll have, let's see, it looks like 3 and 3. 3 that are set up like the first one and 3 that are set up like this one. Okay? Again, when you have an option, like one of them is like this one where this angle B is like the big one, it's like bigger than 90. I kind of steer away from that one at the beginning. It just tends to work out a little bit nicer when you're doing the problems. So, for whatever that's worth. It's still possible. It just ends up being a little bit more difficult. All right, so work at it, okay? Don't just kind of let it, like, whatever, okay? You got to work at it. Okay, also remember quiz tomorrow. No law of cosine on the quiz tomorrow. Okay? So just FYI. All right, have a great day, guys. Good luck. We'll see you tomorrow.